Unit 2, Lesson 2, Scale Drawings. A scale drawing of a diagram or an object can be an enlargement or reduction. So we need to understand what the meaning of enlargement and what the meaning of reduction. Let's say we see a small ant eating a piece of leaf. Actually, sometimes we have the difficulty to see it. We need a glass even to wear a glass to see this ant. So if I want to help the student in grade 3 or grade 4 to see this ant in a science book, so we need in this case to grow a little bit the ant, that let's say its dimension it's only 1 centimeter, to make it a little bit large on a book of science. So as you can see, this picture that you can see it in front of you, it's a picture of ant eating this leaf. So in this case, this is a kind of enlargement. In reality, it's very small ant that it has maybe a length of 1 centimeter. But in a book, I want to make it large like that so student can see it in the science book. So we say this is a good example of enlargement. And how do I know the scale is enlargement or not? When the first term of the scale is greater than the second term, this is enlargement. So as you can see in this scale, it's very clear, 4 to 1. So the first term is greater than the second term. That means I start with large number. That means enlargement. And what about 4 to 1? That means what? If the length of this ant is 4 centimeter on the book, in reality, it's 1 centimeter only. So that's why I need to enlarge the ant in reality in a small book to make the picture clear for the students. So it's 4 centimeter on the book, but 1 centimeter in reality. And that's why we call it enlargement. What about reduction? So I need to see an example of reduction. Let's say the distance between Toronto and Windsor. So the town of Toronto and the town of Windsor, by car, for sure it's gonna take some time because it's large distance. So how can I take this large distance and put it on a small, let's say, card or small image? As you can see, this map in front of us, it's a good example of reduction. In reality, let's say between Toronto and Windsor, the distance, I'm gonna say 360 kilometer for sure. So in this case, how can I draw 360 kilometer on small paper, on small map? In this case, I need something, we call it reduction. So when the first term of the scale is smaller than the second term, this is a reduction. So if you look to the scale of this one, you see a scale of 1 to 10 million. That means 1 centimeter on the map equal 10 million centimeter on reality. What about 10 million centimeter? If I remove 2 zeros, that means I transfer it to meter. From meter to kilometer, I remove another 3 zeros. That means I will reach 1 centimeter on the map equal 100 kilometer in reality. That means if I have on the map 3.6, let's say centimeter, that means it's gonna be, I multiply it by 100, which is gonna be 360 kilometer in reality. This is a shorter example, but I hope that you understand the difference between reduction and enlargement. In enlargement, the large number first and the second number is going to be the smaller. But in reduction, we start with the smaller and after that the large. And if you notice here in both cases, I have one as a small and one as a small even in the second one. So usually the small one is always 1. What about the large one? It depends on the scale. It could be 4, it could be 500, it could be 1000, it could be 1 million, whatever is the scale, we will see it. But as you can see, nothing less than 1. And you will notice something else, that we don't accept any decimal in the scale. It's preferable to use a whole number. Let's start some examples to see how we can solve problems for enlargement or reduction. So let's talk about this example. To make a scale drawing of a painting with dimension 99 centimeter by 69 centimeter, this is the example in the left side, 99 centimeter by 69 centimeter, and we call this painting, on a sheet of paper measuring 27 centimeter by 18 centimeter. That means you have a real painting on the wall that the dimension is 99 by 69. You want to transfer the same drawing of this painting on small paper that the dimension is 27 by 18 centimeter. How we can solve this problem? So I need that you focus how we're gonna do it step by step. Before I start to talk about this example, I need to ask myself, I'm going from painting on the wall to small paper. Is this reduction or enlargement? Exactly. So what you are seeing is correct. I'm going from something large to something small. That means I'm doing reduction. So I'm gonna write reduction. This is the first question that I have to ask myself before I start anything. I'm doing reduction. Excellent. This reduction is gonna lead to what? The second step that I need to understand, that reduction, that means I have a small number to large number. And we said the small number always is 1, 2, something it's unknown. I cannot find it now. I have to do some calculation to figure out this number. So my scale is going to be 1 to something, but I don't know it till now. So let's start the steps, how we can find the scale step by step. First of all, we said small to large. So that means if I'm talking about the lengths of the painting and the lengths of the paper, that means I need to talk about the lengths on the paper because this is a smaller, to the lengths of the painting because this is a larger. So small to large. The small lengths on the paper is 27 centimeter. So 27. The large it's on the painting and the length is 99 centimeter. So the scale is going to be 27 to 99. And as we said, we need to transfer that to 1 to something. So if I want to transfer the 27 to 1, that means I have to divide each side by 27. So 27 divided by 27. What I'm doing in the left side, I have to do it in the right side too. 99 divided by 27. So this result is going to give me what? It's going to give me 1 to something. 99 divided by 27, it will give me something like 3.666. That means I can round it up to 1 to 4. Excellent. If I go to the widths, so I solved the problem of the lengths. Now I need to talk about the widths. Again, if I'm gonna talk about the widths, I need to find the small to large. The small here is my paper. The width of the paper is 18. What about the width of the painting? It's 69. So I need something 1 to something else. That means I need to divide the 2 term by 18. So 18 divided by 18 to 69 by 18, which is going to give me 1, 2. The 69 divided by 18 equals 3.83, and 3 it's repeated. So that means if I round it up, it's going to be 1 to 4. I'm lucky to have the same scale 1 to 4 to 1 to 4. That means if I'm going to choose as a final answer 1 to 4, that means I need to take any dimension from the painting to transfer it to the paper. That means I need to divide by 4. Why I divide? I'm not multiplying. I need to divide because I need to go from large to small. So I need to check if my work is correct or not. In this case, I'm going to ask myself, I know that the length on the painting it's 99. If I divide it by 4, which number I will get? I'm going to get 24.75. Is this 24.75 centimeter? It can fit On my paper, for sure it can fit because I have 27 lengths. 24 is less than 27, that means it can fit. Let's check now about the width. I have 69. If I divide the 69 by 4, which is my scale, it's gonna be something close to 17.25 centimeter. Is 17.25 centimeter gonna fit? Yes, it's gonna fit because I have a width of 18. That means 1 to 4 it's safe and nothing will go out of the paper, and I chose a good scale. Let's go to another example. This example is saying a desktop is a rectangle with dimension of 1.06 meter by 51 centimeter. To make a scale drawing, we need to fit the rectangle on a piece of paper 28 centimeter by 21.5 centimeter. As you can see, this dimension is clear here. 1 meter 0.06 to 51, that means this is in real, like this is something in the classroom. Let's say this desktop in the classroom. I want to transfer this desktop into small paper. So again, my question is going to be, am I using enlargement or reduction? Bravo, as you can see, it's reduction, it's right. I'm going from large to small. Excellent. From the reduction, we said the first term, it has to be small to large. Small means 1 to something. I don't know the scale. This is my work. I'm going to do it right now to find what is the scale that I need to transfer anything on the desktop to a small of paper. Now, the small sheet of paper, as you can see, is 28 by 21 centimeter. As you can see, some people, they are saying, I need small marge here that I don't want to touch it, and I need to draw the desktop inside this area. So let's reduce 2 from here and 2 from here. So I need 24 by 18. So that means you want to transfer the whole desktop from 1 meter and 6 centimeter and 51 to a small drawing 24 by 18. How we can do that? Again, we will exactly use the same steps that we did before. We're gonna use it again. So I'm gonna say what? If I have a reduction, let's talk about the lengths as usual. So I'm gonna talk about the lengths. We said the scale, it has to be small to large. What is the small lengths I have here? It's 24. So this is on the paper, 24. 2. The length of the reality, it's 1 meter 0.06. I cannot use in any scale two different units. I cannot say 24 centimeter to 1.06 meter. I have to transfer the meter to centimeter. That means I need to multiply 1.06 by 100. So it's going to be 106 centimeter. So this is the scale. Now, again, we need a scale that it starts with 1, not a large number. So I need to transfer this one to 1. That means 24 by 24, it's going to give me the 1. In this case, I have to divide the 106 by the same number to keep the balance between the two ratio. So 24 divided by 24, it will give me 1. 106 divided by 24, it's approximately 4.416, something like that. In this case, as you can see, the scale is going to be 1 to, let's say, 5, round it up. Now let's talk about the widths. Now again, from small to large, that means I'm going to take the width of the paper to the real width of the desktop. So the width of the paper, in this case we said 18 instead of 21.5 because I need to leave some margin. So 18 to 51 centimeter. And the 51 here it's centimeter and 18 is centimeter, so I don't need to do anything. Now I need to reach the 1, so that means 18 divided by 18, it will give me the 1, and 51 I have to divide it by 18 to keep the balance. 18 divided by 18, it's 1. 51 divided by 18, it's approximately 2.83, and I have to repeat the 3. So if I round up a little bit, it's going to be 1 to 3, because we said we don't accept decimal. Now we have a good question. Do I follow the 1.5 or do I follow the 1.3? This question is very important because I need to know which one I'm going to use. So if I'm using the 1 to 5, that means I take any dimension and I divide by 5. If I'm going to use the 1 to 3, I'm going to take any dimension and I divide it by 3. Which one is safer? For sure, in this case, the 1.5 is safe than 1 to 3. Why 1 to 5 is safer than 1 to 3? The 1 to 5, it guarantees that everything from the drawing here, it's gonna fit in the paper. But the 1.3, I will be at risk. Sometimes, maybe it's gonna go out of the range of the paper. So I have to divide it by the larger number. 5 is larger than 3, so it's safer than 3. To avoid any surprise that any dimension will go outside of the sheet of paper. So I need that you understand this one. This is in case of reduction. What about if I'm doing enlargement? The opposite, it's right. It's safer to take the smaller number, so I'm going to explain it after when it comes to enlargement. Let's go to another example. On a map of Ontario, the straight line distance between Windsor and Toronto is 3.6 centimeter. The scale on the map is written as a ratio of 1 to 10 million. Calculate the actual distance between the two towns. For sure, it's impossible that the distance between Windsor and Toronto is going to be 3.6 centimeter. We need to understand that this is on a map, on paper, not in reality. And actually the question is, calculate the actual distance between the two towns. This is what we need to know if I'm going and I'm renting a car, how many kilometers I need to drive and how long it's going to take, let's say by, let's say in 2-3 hours, it depends. So let's start to ask myself again, this example, is it reduction or enlargement? As you can see, I have something in reality that is very big, and now I'm trying to put it on card. That means it's this scale, it's going to be reduction again, because I went from reality to small map. So I'm doing reduction to draw it on a map. Now the question is saying calculate the actual distance. In this case, I have to think about that I'm doing something related to an enlargement. So the distance of 3.6 has to be large number. Excellent. The scale is saying 1 to 10 million. That means 1 centimeter on paper equal 10 million centimeter in reality. Excellent. Now, what is the distance between Windsor and Toronto on paper? It's 3.6. What about the actual distance? And this is what we are looking for. So I have to find a way, how can I solve this problem to get the real distance? So there is many way of calculating this one, but the easiest one, if 1 centimeter in reality is 10 million, what about the 3.6? That means in reality the distance equal to what? Equal to 3.6 times the 10 million. Before, in the previous two examples, we divide. Here we need to multiply. We need a large number because this is going to be the reality. So 3.6 times 10 million. You know that if I'm multiplying, I need to move the decimal point to the right side. How many steps? As you can see, 10 million means 7 steps. So I'm going to take 36. This is the first step. And after that, I will add the 6 zeros. That means 36 million centimeter. Now I need to transfer this one to kilometer. So from centimeter to meter, I move 2 zeros. From meter to kilometer, I move 3 zeros. That means 360 kilometer I need to go from Windsor to Toronto. So if I need to rent a car, I will know that I need to drive 360 kilometer. And in this case, I'm gonna say, okay, if I am driving on, let's say, with a speed of 100 kilometer per hour, that means it's gonna take from me approximately 3 hours and half or 3 hours and 45 minutes, something close to this time. And this is how we can find the real distance when I'm using a scale on a map. Let's go to another example. The scale of a leaf cutting ant is 3:1. Calculate the actual length of the ant. Again, the first thing that I need to focus and I need to understand and I need to ask myself, this scale in front of me, it's enlargement or it's reduction? First of all, here it's helping me to understand that the scale is 3:1. We said before, if I have 3:1, which number is large? This is a large and this is a small. When you start with large, that means it's enlargement. Exactly. Now, if this is a case of enlargement, I need to understand it. That means what? That means maybe the ant is very small in reality. And after that, I need to take this ant and I need to add it to a picture in a science book for the student so they can see it. And as you can see the distance here, the length is 4.9 centimeter. The question is saying what? Calculate the actual length. So I need to know the actual length of the ant. If I go in reality and I need to see how is the length of the ant in reality, how much. So this is my main question. So how can I figure out the steps? How can I do it? In this case, I need to understand the scale and I need to understand how can I find the proportion of lesson number 1. Do you remember the proportion? We said the proportion is ratio equal to ratio. So I need to find the first ratio that it equal to a second ratio. Now, if I have already a scale 3:1, 3:1, this is my scale. I know that the 3 is a large one. That means this is on paper. But the 1, this is in reality. So let's talk about what do I have as a distance. I have on paper already the 4.9. So that means I have to add the 4.9 here in this side. And I'm looking for the actual length of the ant. So it's going to be 4.9 and to something equal to 3.1. And this is my question now. How can I find this answer? I can transfer everything to a fraction. I can say what? If I have 4.9 over, let's say, x equal 3/1. Now some student will say, okay, I need the x to be in numerator, not denominator. No problem, you can switch it. X over 4.9 equal to 1/3 if you like this shape. Now I need to isolate x to find the value of x. As we noticed before, we can do it with an algebraic way. I can say I have x over 4.9. To isolate the x, I need to multiply this side by 4.9. So I can simplify 4.9 with 4.9. But I cannot do this one in the left side and neglect the right side. I have to do the same change. So 1 over 3 again times 4.9. Now I have x only equal to 4.9 times 1, which is 4.9, divide by 3. I will get 1.6 centimeter, and this it will be my final answer. This is the correct answer. This is the reality. This is the actual length of the end. And as you can see, 1.6, this is a reality. I draw the same end on a book but with 4.9 centimeter. Why? Because I need to use enlargement. I need that the student can see the end on a science of on book of science, so they can see it with enlargement with a bigger or larger size. I hope you understood this lesson with the enlargement and with the reduction, and see you on the next lesson, which is Unit 2, Lesson 3. Thank you.